is the science of stupid. Warning! The stunts in this program were performed by the scientifically impaired. Do not try this stuff yourself.
Zip lines. A fun and scenic venture for thrill-seeking individuals who don't have a fear of heights. Zip lines, which were once not very common at all, are now all across America. Just in 2001, there were only 10 zip lines in the US, and now this outdoor adventure has boomed. Zip lines can be thousands of feet long, or simply from one tree in your backyard to the next. Either way, the creator of each zip line must understand the physics behind it in order to have a fun and safe ride down the line. Otherwise, the results can appear pretty stupid.
Two primary forces that affect acceleration. One is due to the component of gravity in the direction of motion, and the other is a combination of friction and other resistive forces. On a zip line, the force of gravity acting on the rider's mass produces the dominant or the main force. Force vectors, like the one shown in the diagram, are said to be two-dimensional force vectors. You can think of them as forces that have a part that pushes right or left, and that have another part that pushes up or down. These parts of the force are called the components of force, and they are caused by the angle of the cable. The component that pushes right or left is called the x component, and the part that pushes up or down is called the y component. Tension has both x and y components in zip lines. There is tension from the cable, and there is force of gravity from the hanging person. The cable of the line should be angled so the person can actually accelerate down the line. There is frictional force that occurs when the rider pulls down on the line through a pulley system. Because of the natural decline, there is less friction, also causing the person to accelerate. This clip shows the man who doesn't make it till the end of the zip line. In the slow-mo, this man didn't make it till the end because the cables are at a steep incline. In the video, the cables are horizontal rather than inclined to the water. Looking at this video in slow motion, this stunt failed because the y components of tension did not balance out the force of gravity. The wire was angled too far, so there was less tension, which gave the cable extra slack. Therefore, the boy dropped slower than he intended to. In both failed videos, gravity is what causes the people to accelerate. In the trampoline clip, in order to keep the boy from hitting the trampoline, the cables need to be tightened, resulting in smaller angles to the horizontal axis, which would increase the total tension. In the clip where the man stopped in the middle of the zip line, the cables need to be at a greater incline so that the man can make it till the end. This would result in a greater component of gravity pulling him down the cable, so he would then make it down to the bottom successfully.
To the science of stupid.